My name is Jason Bordoff. I'm a professor here at the School of International Public Affairs at Columbia and director of the Center on Global Energy Policy here at Columbia. And it really is a privilege to have Adam Sieminski, the administrator of the Energy Information Administration, here with us today on Columbia's campus. We've all seen, seems almost every single day, new headlines, new reports about the magnitude of the North American oil and gas renaissance. The U.S. is the largest liquids producer in the world, having just overtaken Saudi Arabia, the largest crude oil and gas producer in the world, having overtaken Russia, is no longer the largest oil importer, largest refined product exporter. On natural gas, the numbers continue to surprise to the upside. We're building export terminals for natural gas now. So the world has changed really quickly. But even in the midst of all those headlines, you hear a lot of questions being raised about exactly how significant this U.S. oil and gas boom is and really will be. We're still in early innings of this game, especially for liquids. You hear, lots of different views on how steep the decline rates are and what well productivity looks like for tight oil and shale gas wells. And so it's really critically important to help understand what the future outlook of the U.S. energy picture is to really have the best possible data on well productivity and decline rates. And so it's, I think, to the credit of Adam and his team at EIA that they took this on. They recognized this need for this information to help us understand what's happening in the North American energy space. And then, as EIA does, went out and got that information, pulled it together, made it publicly available so everyone has it. So I'm really happy that Adam is here with us today to present this new research and tell us what EIA found and what sort of data they'll be collecting moving forward. You all have Adam's bio. It was on the table when you walked in, so I won't go into it in too much detail. He was recently sworn in as the 8th administrator of EIA. Before that, had served in the White House as Senior Director for Energy at the National Security Council, which is a wonderful job because it's a job that I also had. And before that was the Chief Energy Economist at Deutsche Bank and has been at the Center for Strategic International Studies, former president of the U.S. Association for Energy Economics, president of the National Association of Petroleum Investment Analysts, and on with his affiliations, his academic work, his think tank work. And is just a true gem of a person and a really wonderful person, a wonderful friend, very generous. I learned an enormous amount from him during my time in government, continue to learn an enormous amount from him, and I'm really happy that he's with us today so we can all learn from him. So please join me in welcoming Adam Sieminski.
Jason, thank you for that very kind introduction. What Jason didn't tell you was he was smarter than I was when he got to the White House for that job. He held out for White House mess privileges. That means you can, go to the dining room that's in the West Wing of the White House. That was really pretty cool. So one of the first things that Jason did when I got over to EIA, he invited me to come back to have lunch at the White House. Thank you, Jason.
You're welcome. Can I have lunch at Columbia anytime?
Right. So happy to be back here. I was up 6 months ago, Jason, was it, for the LNG seminar, workshop that Jason held. And I was actually, came here when I was a sophomore in college to Columbia to an event for civil engineering students. So it feels like Columbia feels a little bit like home, but a very distant one. Okay. The purpose today is to talk about EIA's drilling productivity report. So this is something that Jason indicated we just launched last week. We've been working on this for a while, but it's part of an effort that I've been pushing EIA towards, that if I were going to try to describe this, EIA has a lot of historical data, and we do a lot of long-term forecasts. But in the middle, and what I call, energy now, there are a number of things that we do, but EIA had not been, in my view, doing enough on kind of current events and what they mean for policymakers and the public. And I think this helps to fill that gap. So why are we interested in this? everybody's seen these charts, so I won't spend a lot of time here looking at these, but a huge, huge increase in tight oil, shale oil production since 2005, and similarly for natural gas. In fact, the real exponential growth on the oil side has been more recent. I mean, the gas thing started back around 2005, but oil didn't really get going until 2009, maybe 2010. So one of the questions I think that's coming up is oil going to follow a path similar to what we have been seeing on natural gas? And in fact, can both of these fuels continue to grow in the U.S.? And I think the answer is, for the near term, very little question about that. For natural gas, EIA has no doubt at all that production can continue to grow all the way out to 2040. Right now, tight gas is about a little over a third of U.S. production, and we think it'll be close to half of U.S. production in 2040. For oil, it's a little bit different, and views differ on this, and even EIA's views are evolving. But we think oil production can continue to grow quite a bit from where we are now. Might plateau as we get out into the next decade, but at levels significantly higher than where we are now. So these are the takeaways from our drilling productivity report. Higher drilling efficiency and new well productivity are really the main drivers of what's happening, not the rig count itself, when you think about production growth. The 6 plays that we are looking at, and I'll show you a map of these in a little bit, but it's Eagle Ford, the Permian, Haynesville, Niobrara, Marcellus for gas in Pennsylvania, and the Bakken in North Dakota. Those 6 plays that do have steep legacy production declines, but nevertheless, the growth that's taking place across the board in those 6 plays is beating productivity declines by almost 70% for oil and almost 3/4 for natural gas. So understanding both the positive and negative forces that are affecting production volumes is critical. And looking at this on a regional basis in these 6 basins is allowing us to figure out how many rigs are required to make up for the production losses from existing wells. And one of the final things is that looking at this from the standpoint of both new and existing wells and looking at those things separately really highlights how these plays can continue to grow. It's not that long ago, maybe 10 years ago, that the idea of peak oil and maybe even peak gas was very prominent in the literature. And breaking things up in this way, I think, allows us to think about this much more carefully. So a little bit of drilling history, and I'll go through this kind of quickly. There is a period, and I remember this as an analyst following the energy industry in 2007, 2008, when gas production and the natural gas rig count seemed to be moving along in a similar direction, leading a lot of analysts to think about using the rig count as a predictor of production. Now, if you look backward in time, and you go back to the earlier part of the last decade, there were certainly plenty of times where the rig count in red was moving around and gas production wasn't doing all that much, although arguably the production numbers were being constrained by what demand was, so you might have to take a quicker look at that. But the really hard bit to explain in this is this one. The huge drop in the rig count that took place in 2009, which at that time had most analysts convinced that surely gas production would follow in terms of moving downward. And what really ended up happening is gas production just kept climbing. So in the famous words of Lucille Ball, Actually, I think it was Ricky. Lucy, you got some splaining to do, right? So what's the explanation for this? And I think the answer is technological advances. But let's take a look at this again from a general standpoint. So you see the huge drop in the gas rig count. The oil rig count came down as well, not as much as the gas rig count did, but that gas production number continued to climb. The general conclusion here is that neither the gas-directed rig count or the oil-directed rig count, and that's what you see here. So oil-directed rigs, that lower solid line, the green line, total rigs, so that includes natural gas, and oil production. So look at the far right-hand side here. Since January of 2012, the total rig count flat to down, the oil rig count climbing a little bit into the first half of 2012, but then going essentially flat. And now oil production rising. So we're beginning to see in oil what we saw in 2009 and 10 in natural gas. So what accounts for this? Well, one thing is that the percentage of wells that are producing both oil and natural gas are climbing. So that number was closer to a third back in 2007, and it's well over 50% in 2012. So wells are producing both oil and gas. And so if you're producing oil and drilling for oil because the price is attractive and the technology is letting you do it, you're getting a lot of natural gas liquids and natural gas as a byproduct. You can see this in the count of new wells by production type. So that last graph was in percentage terms, so all adding up to 100%. This one is in the number of new wells being drilled in a given year, and you can see the both is climbing since 2009, and the gas directed only coming down quite a bit. So now let's look at, well, is there some explanation for this? Well, of course, one, not the only one, but a main one, is that the drop in the gas price, that blue line there, resulted, as I said, in producers looking to shift away from drilling for natural gas and concentrating on drilling for the liquid portion of the barrel that was selling for more. So natural gas producers basically were adapting their drilling in line with the market value of the products that they were getting. So the drilling productivity report that EIA put together said, look, we can't just look at the rig count anymore. The Baker Hughes rig count is still a very valuable tool, very valuable number to have. But it's not the only thing, and it's not by itself sufficient to help you understand what's going on with the productivity of both oil and gas. In addition to the rig count, you need the well classification. You need to know what the drilling efficiency is. How many wells can you drill? How quickly? How many feet? How far out can you go horizontally? What's the productivity of those new wells? How many segments can you fracture, along the line? What do those stages, multi-stage fracturing, produce? Can you learn through technology which parts of the well bore to fracture and which parts might not provide the kind of productivity in terms of output that you would be looking for? How do you wrap all that together in terms of legacy declines or depletion trends along with production? So here are some numbers that fall out of the drilling productivity report. In Eagle Ford, for example, and that's in Texas, wells per rig per month. So we see this climb that started in late 2009, a lot of wells being drilled per month, and beginning to taper off as you got into 2012 and into 2013. But if you look on the right-hand side, what you see is first full month production of both oil on the left-hand scale and gas on the right-hand scale, and those oil numbers continuing to climb, basically saying that even with fewer wells drilling per month, the amount of oil that you were getting out of the well was sufficient to keep overall production still climbing. Not so much with natural gas, but that's not a surprise given the price of natural gas and the differential in pricing between oil and natural gas. So here are the 6 key plays I mentioned earlier: Eagle Ford and the Permian, Haynesville. So Eagle Ford, oil and gas; Permian, oil and gas, but I think people are really looking for oil now. Haynesville, a gas play; the Marcellus, a big gas play; Niobrara, both oil and gas; and the Bakken, more oil than gas for sure at this time. These 6 key plays have accounted for almost all of production growth from the U.S. fields over the last 2 years. Some 90% of domestic oil production growth and virtually all of domestic natural gas growth is accounted for in these 6 key plays. Bakken and Eagle Ford together account for something like 67% of monthly oil production growth. So Bakken and Eagle Ford together, 67% of the growth in U.S. oil production. Over the past year, production in these 2 key plays increased by nearly 700,000 barrels per day. The Permian play remains the biggest absolute oil producer. So in total terms, one of the largest. It grew by about 93,000 barrels a day year over year over the course of the last 12 months. Remarkable. I was quoted in a story in the Wall Street Journal a few weeks ago saying, never in a million years would you have guessed that this was going to happen. That may be a slight exaggeration, the million years, but certainly not in my lifetime would I have guessed that a development of this size, scope, and importance would be taking place. So now I'm going to drill down a little bit into the DPR methodology, how we did it. Won't spend a lot of time on this, and I'll try to give you some of the takeaways, and then we'll see what kinds of questions you might have. So this is basically how we do it. Monthly additions from one average rig. So this is our estimate of how an average rig across these plays, so individually within the 6 plays, contributes to oil production and natural gas from new wells. Then we look at the new well oil and gas production per rig. So this represents a historical estimated monthly addition from, again, one average rig coupled with the number of total drilling rigs. So that gives you the total amount being produced in each of those plays. Then we look at the legacy oil and natural gas production change. So that's basically downward. I guess we could say that oil and gas production decline. This is our estimate of the total oil and gas production changes from all the wells other than new wells. This trend is dominated by depletion rates. So that's the legacy decline. There are other things that can come in there. If you have a hurricane in the Gulf and you have to shut wells in, for example, that can change the near-term values of the production change. Then we bring this together, combine the effects of both new well production and then the changes in legacy production. That gives us an overall number of change in both oil and natural gas production. And then we take that change and add it to the prior month's production number to give us a forecast of what we think current production is and what the next month or 2 of production will be from these wells. So one of the things that we learn from doing this is we can get an idea of how many rigs have to be running in order to sustain, so to keep production of oil and natural gas rising in these different plays. So here what you see is in the Eagle Ford, despite this last year's worth of decline in the rig count, the overall rig count in Eagle Ford. The gap between the black line and the sort of brown colored line for oil and the blue colored line for gas tells you that there are enough rigs running to keep production going up. So if at some point the black line were to come down or the other lines were to go up fast enough to cross over the black line, that would be a signal that you're likely to begin to see the production change going negative. That would suggest that production could be falling, but we're nowhere near that point in the Eagle Ford. This is the picture for the Bakken. You know, again, even with a decline in oil rigs drilling, the gains in productivity for both oil and gas are sufficient that there is still a gap between how many rigs are running and what number of rigs, either oil or gas, are required in order to sustain production growth. So what that says is, over the near term, production is still going to go up in both the Bakken and the Eagle Ford. One of the other things that we get out of this is a little bit better idea as to what current production is. Right now in EIA's data collection process, there are lags. The states vary in terms of their reporting procedures. Some states are better than others. If you have a state with a lot of independents operating, the lags in reporting tend to be longer. So Texas, it takes almost 2 years before you get all of the data in for a given month in Texas. That lag is a lot shorter in a state like Alaska, where there's, you know, everything is dominated by the North Slope and there aren't that many operators, and so the data comes in much faster, just as an example. What we can get out of this at EIA is a much better idea of what current and future month production is relative to the typical lags in data that we have, and this is enabling us to have 3 or 4 months better data. All right, I've got a few backup slides here. Let me just show you what these look like. These are going to be available. Jason will post them. They'll also be posted on the EIA website. I'm not going to go through all of this, but what I have here is, first of all, a picture that shows what the report actually looks like for one of the regions. So this is for the Bakken. And on the left-hand side, you have oil. On the right-hand side, you have gas. We start out with what the monthly additions are from one rig. The second thing down, those two graphs are the overall new well oil production coming per rig, along with the rig count. The third sort of grouping down is the legacy declines. That allows us to calculate the fourth line there, and that is the indicated change in production. And then the indicated change in production for the last month's production allows us to say what we think production is. What you see here is that oil is far more important in Eagle Ford or in the Bakken, than natural gas. So what I'm going to show you in just a little bit is data for the Bakken on the oil side and Marcellus on the gas side. So this shows you that first step, how we calculate what the additions are in production coming from a single rig. And here you see growth coming in both oil and gas in both of these plays, but you're getting a lot more gas coming in the Marcellus and you're getting more oil coming in the Bakken. So now I'm showing the Bakken on the left-hand side and the Marcellus on the right-hand side, and this is the step 2 in the methodology, and this is that new well oil production and new well gas production per rig in each of these plays, along with the rig count. This is the third step that shows the legacy production declines. You have to be careful on these scales. What looks like a huge decline, these scales are pretty small. This is only 70,000 barrels a day in the Bakken and 200 million cubic feet a day, or 0.2 BCF a day in the Marcellus in terms of the change. One of the things that you see is in the Marcellus, interestingly, that change is leveling out, so we're not seeing legacy declines accelerating in gas in the Marcellus. This is the step 4, how we take all these numbers and combine them to come up with what the indicated change in oil production or natural gas production is. So again, production up from new wells, legacy production down, and net change still positive in both of these cases. Then we add that to the prior month's production to get total production. One of the interesting things in the Marcellus, and this is monthly natural gas production, million cubic feet a day. Right now, the Marcellus is producing something like 12 billion cubic feet a day of natural gas. Total gas production in the U.S. is about 70 billion cubic feet a day. So the Marcellus is an enormous addition to gas production in the U.S. So there you go, a deep dive into the drilling productivity report from EIA. I'll be happy to answer any questions on this and would be pleased to talk about other things if you want to do that.
Great. Thank you very much, Adam. So we have microphones that people will pass around. There's an attempt at applause, so yeah, please. Thank you for doing that. And thank you, Adam. So we'll pass the microphones around to take some come up there to ask questions? Yeah. Okay, so if people just go stand at the microphone, and we'll take questions in the order in which we have them. About the well productivity report or about other current energy issues as well. We have a little over a half hour. I'll just throw the first one out, which is sort of to come back to the way that I introduced the topic and why, even though it was a little technical and a little wonky, I thought it was really important, Adam, for you to come and talk about this because it gets at this fundamental question of how much do we really have. And so if you look at the range of estimates out there for shale gas and tight oil, there's variance, more so for oil than for gas. The estimates, if you put them on one chart, kind of move around a lot. Some people see us production going up and up and up. Some sort of see it plateauing in just a couple of years, starting to come down. EIA in its most recent annual energy outlook is a little more on the conservative side, where production peaks toward the end of the decade and then starts to decline. Just in response to all this new information that you guys have collected, I'm wondering if you think that'll look different in the future, and if you think differently about how much oil and gas the U.S. really has as a result of this unconventional technological innovation.
So what the drilling productivity report doesn't address is the overall resource base that the U.S. has, which seems to be significant, certainly for gas, probably for oil. One of the things that I think we're learning from the drilling productivity report is that technology really, really matters. I'm going to go back to 10 years ago and one of the theories from peak oil. The peak oil hypothesis was largely based on two driving assumptions. That technology didn't matter and prices didn't matter, and the reason that they didn't matter is because the resource base was well known, and once half of the resource base was actually developed, the inevitable declines in production would follow. So I think that one of the things that has clearly been learned over the course of the past few years and is shown in this drilling productivity report is the importance of technology and the importance of price in helping to drive that technology is absolutely critical to understanding this. So I think, Jason, the short answer to your question is we don't know, but one of the things that the drilling productivity report is showing is that in the near term, that there is still more room for growth in both oil and natural gas production in the United States, and probably a lot more.
I'm happy to keep asking questions, but there's a lot of smart people in this room, I know, because I know many of them. So if folks can we pass the microphone around, or do people have to come up here? Okay, if people could just come and stand at the microphone, I guess, that seems to be the preferred way to do it. So, yeah, if you could identify yourself and please keep the question quite short and brief and make it a question, not a statement. Thanks.
Hi, Michael Diddick from Columbia here. Just along the same lines with technology, but moving international, there's been some debate about what the U.S. policy role should be in sharing technological innovation with China and helping to develop their reserves. And I just wanted to know, what's your perspective on that? And also, if China does develop their reserves, what impact is that going to have on the potential for LNG exports in the U.S. when all of a sudden you have a very supplied Asian market?
Well, one thing that Jason didn't say, but this is always gives me an opportunity to say, is that the EIA, the Energy Information Administration, is not a policy organization. We're kind of like Sergeant Joe Friday in Dragnet. Just the facts, ma'am, just the facts. So should the U.S. encourage the export of shale and drilling technology to places like China, the State Department, which is a policy organization, under Secretary Hillary Clinton, made a huge effort to do just that, to try to spread U.S. technology for shale drilling and production around the world. And some of that you're beginning to see in places like Poland, Colombia, South America, Argentina, parts of in fact, this gives me an opportunity to talk about one thing that EIA did do. Is a couple of years ago we published a study on what the shale gas resources were on a global basis, and just 3 months ago we updated that study for natural gas and added for the first time shale oil to the agenda. And our conclusion there was that there is a lot of tight oil and gas resources around the world. Hold on just a second. I'm going to get my cheat sheet on that and read it to you. So if you go to EIA's website, you'll find this study that we did. And on the oil side, our estimate of recoverable shale resources, we had Russia at 75 billion barrels. The U.S. is 58 billion barrels. So Russia actually has more tight oil or shale oil than the U.S. does from a resource standpoint. Also high on that list, China, Argentina, Libya. If you go to the gas side, China at over 1,100 trillion cubic feet is nearly twice the level of the U.S., Argentina at 800, Algeria at 700, Canada at almost 600, Mexico at almost 600. So there are a lot of these resources around. Trying to avoid making a policy judgment as to what we should or should not do, I would observe that consumers generally tend to be better off when there's a lot of competition, and having production outside of the U.S., healthy oil and gas production in countries, whether it's China or anywhere else in the world, has generally been seen as a positive to help keep markets balanced. What we have seen in the past year and a half or so has been a lot of non-OPEC oil production outages, problems in places like Sudan, Yemen, Syria, and elsewhere, and drop in oil production has actually caused OPEC's spare capacity to shrink a little bit, and that's tended to keep upward prices, pressure on oil prices. And so I think you could go back and say, in answer to that question, is it a good idea to encourage nations all over the world, not just China, to produce more oil and gas? And the answer is yes, assuming that you can properly handle the environmental consequences of doing so.
And I would just add to that one of the key point people in the administration for 4 years dealing with the U.S.-China energy relationship was David Sandlow, who was acting under Secretary of Energy and who in the summer joined as the inaugural Distinguished Fellow at the Energy Center, who'll spend the next year studying the potential for shale gas development in China. So we'll have more reports and more events and research coming out.
The second part of that question, I'll make this one really brief. On LNG exports, again, permitting LNG exports is actually something that the Department of Energy is responsible for. That's the Office of Fossil Energy, not EIA. EIA has looked at what we think is going to happen with the Cheniere Sabine Pass plant and others in our models, and our conclusion is that there's enough natural gas in the U.S. to allow for exports and not have a significant impact on prices.
I appreciate people waiting patiently and standing. Please.
Yeah, hello. My name is Bruce Robb, and my question was more focused on costs of lifting natural gas, liquids, and oil. And on the tight oil plays in particular, your presentation was very focused on production. And I'm just curious if you've done any work on technology and how that may be affecting the lifting cost of the various fuels. And I guess the same question another way, is there a price of natural gas or oil where suddenly these tight oil plays and shale plays and gas plays become less economic?
Right. I think if we assumed that the technology was static, then the answer is we could probably find what that price was for gas or for oil. Let me just try to answer it a bit on the oil side. If I go back to, what Lucy had some explaining to do about, and maybe analysts in general, including EIA, was that in 2006, 2007, I think even as late as when the rig count started to come off significantly in 2009, that the marginal cost of natural gas production, I think, was estimated to be very high, maybe $9 a million BTUs, maybe even 10 and climbing. We could look back at what EIA said, but you could look back and find what almost anybody was saying at that time. And shale gas was thought to be at the upper end of the marginal cost curve. So what happened was a combination of horizontal drilling, multi-well drilling off of single pads, multi-stage hydraulic fracturing, all kinds of improvements in drilling technology drove that marginal cost curve down. And what we've seen is that, even prices, natural gas prices didn't really stay at $2 to $3 long enough to really test the hypothesis. But at prices near $3.50 to $4, I think that there's a view that says gas production in the short run can still climb. That maybe it might take $5 gas in the long run to continue to have gas production go up. But if the technology continues to improve, that'll put downward pressure on those cost curves, and I think we're seeing some of that. The next big development that is going to, is already taking place, but we're going to see over the course of the next 3 or 4 or 5 years, is the idea of multi-stage fracturing, hydraulic fracturing. So right now, the typical lateral length in Eagle Ford is about 6,000 feet, so a 6,000-foot horizontal well. And you might have 20 stages, frac stages, in that 6,000-foot segment. But it turns out that of the 20 segments stages that you're fracturing, maybe only a third of those are producing 85% of the production, and the other 2/3 are only producing 15% of the production. So make it easier. Let's just say that half of the stages are producing 80% of the output. So if somebody can figure out ahead of time which of those stages, which are the half of the 20. So of 10 of those are going to produce almost all of the production, and 10 are going to not be producing very much. So if you can identify ahead of time, which of those are not going to produce, and you just don't frack those, you can cut the amount of water that you need, you can cut the amount of pumping horsepower that you need, you can essentially dramatically lower the costs of producing the gas from that well by only fracturing half of the well segment. And that's what the companies, service companies, and the producers are beginning to tackle and beginning to understand. And when they figure that one out, we'll be on stage 2 of this revolution.
Please.
Hi, my name is Sabina Zavatsky. I'm from Reuters. I have a question about the actual report that came out, I think it was last week, because we compared some numbers with what various analysts had for both Barkin and Eagle Ford, and the numbers vary very wildly. I think none of the analysts...
Who were you comparing the numbers?
Woodmac and IHS.
Right, Woodmac, right.
Yeah, so none of them had, for example, Eagle Ford at over $1 million, which you guys did. And I asked them their methodology, and they say they actually look at the company statements a lot more. They look at the kind of commercial aspects of, would companies be investing, would they be, raising, drilling, and so on. So, I mean, I guess the question is, how confident are you with your numbers? Or, is there some credibility for the other methodologies? And if I may, I have a second question also, which is, with all of this rise, which is unexpected, unprecedented in oil production, do you think it makes sense that the U.S. will start exporting crude at some point? Thanks.
Right. So the first question is, how confident am I in the numbers? So that actually leads me to kind of a general, as an analyst. I remember when I was in the private sector that I was quite happy if I was right about 55 or 60% of the time. You kind of go, really? And the answer is yes. If you thought about playing blackjack, you could be very rich at that kind of a uncertainty ratio. So are we going to get all of these numbers perfectly correct? The answer is no. Am I surprised that Woodmac or IHS, CIRA, or Bentac or any of the other groups that have looked at this would have different numbers? No, I'm not surprised at that. Even in the financial community, there is a wide range of views, with some people in the financial community saying that a decline in production is just around the corner, and others saying that this boom could go on for a very long time, and we could see oil production in the U.S., crude oil production as high as 14 million barrels a day. So there's a huge range of opinions on this. I think that the work being done at EIA is among the best efforts made in this direction, and I'm confident that at least on these short-term numbers that we're quite correct. Longer-term forecasts, the main purpose of longer-term forecasting is to make astrology look good. The long-term forecasts inherently are not about the end number. They're about the assumptions and methodology that you use to try to do the projections so that you can test what changes in those assumptions and what changes in the methodology do to the sensitivity of your forecasts. And so from that standpoint, I think that the work that EIA is doing will stand up pretty well against the outside consultancies, and so we'll just have to see over time how that works out.
Did you want to
exports of crude oil? So
and can you just take 2 seconds to explain?
Sure.
So
crude
people,
oil,
even if we're a net importer, explain why it's still an issue.
The U.S. currently is producing, if you just kind of round these numbers off, we're producing about 7 million barrels a day, and we're importing about 7 million barrels a day. It's like of crude. If you think forward and you say domestic production is growing, domestic demand is declining, the U.S. Is moving away from being a very large net importer of crude oil. In fact, the U.S. Is now importing less crude oil than China is importing. That's an interesting marker. That crossover just took place this month. The U.S. is producing more total liquids, so that's crude oil, natural gas liquids, biofuels, and something called refinery gain. You get a few more barrels coming out of a refinery in products than what you put in because light products take up more space in a barrel. If you add all of that up, the U.S. is the world's largest liquids producer, petroleum producer. We're producing more oil than Saudi Arabia. We're producing more oil than Russia. In EIA's forecasts, the U.S. continues to be a net importer of oil all the way out to 2040 in our reference case. If you take side cases and you do a scenario that says, what if demand comes down faster? What if supply is more robust than we think? Is it possible that the U.S. could become a net exporter of oil in general? And the answer in our side cases was yes, sometime after 2030, that's a possibility. There's kind of interesting issues associated with that. The U.S. could be could be a net exporter of oil, and we're still part of the global oil market. If oil prices go up because there's a supply shortfall somewhere, and the one that everybody loves to talk about the most is what happens if there's a problem in the Strait of Hormuz. There's 14, 15, 16, 17 million barrels a day of oil that goes through there, and that could be a real mess on global markets if something should curtail the flow of oil through there. If oil prices go up, they go up all around the world, and they go up in the United States as well as everywhere else, even if we were a net exporter. For pricing, the U.S. is still part of the global market. For lots of foreign policy reasons, we're still part of the global market. The elusive goal that was set by many presidents over many years of energy independence, might be a bit like a dog chasing the car. Once you catch it, then what? The one advantage of producing more and consuming less is that your balance of payments is better, and if prices do go up, those payments are going to domestic producers rather than producers outside the U.S., and there may be economic advantages to that. Would the U.S. be an exporter of oil? We already, we do export crude oil to Canada. When I first became EIA administrator in June of 2012, I said that policymakers at some point might want to think about the possibility of doing things like swaps with countries in Latin America, particularly that have heavy oil. We've got a bunch of refineries in the Gulf Coast of the United States that can run heavy, high sulfur crude oil, and all of this shale oil is light and sweet. And the refineries in the Gulf Coast are more efficient if they're running heavy, high sulfur crude than if they're running light, sweet crude. Mexico, Venezuela, Colombia, I can think of a number of countries in Central and South America that might benefit from some kind of a swap. We send them some of our light, sweet crude, and they send us some of their heavy, sour crude. And both countries gain from it economically, and I don't think it would really harm U.S. energy security. So that kind of thing is certainly a possibility. Beyond that, it's a policy question that policymakers are going to have to deal with.
Thanks. I noticed the line is short, so people should, if you have questions, go and stand in the back of it. We'll get a few more questions in, please.
Hi. We're trying to figure out the future of the rail industry and the expansion of these energy resources.
Right. So the question was, what about rail? And, you could broaden that out even and talk about infrastructure in general. One of the amazing things is this growth in production in the Bakken, and we're up to almost 1 million barrels a day of oil production in the Bakken. So 1 million barrels a day of oil production in a part of the United States that 10 years ago nobody really thought was going to be a big oil producer. North Dakota is the second largest oil producer in the United States now. That's a remarkable development. It's pretty far away from consuming centers, though, so that oil has got to get out, and the way it is going to get out is either by pipeline, rail, or truck. I remember I actually was doing a calculation that is there anybody, I'm looking around, is there anybody in this room as old as I am? So when I was growing up, Ed Morris will remember 20 mule team borax. There used to be this ad on TV, and they were showing hauling borax out of the desert out in the Southwest with a mule team, 20 mules pulling a wagon. And I was thinking that the differential between what oil was worth in North Dakota and what it was worth in Oklahoma and particularly Texas was sufficient that if I could get 20 mules in a wagon, I could probably make a lot of money hauling oil from the north to the south. The railroads figured that out, and they figured that at the kinds of differentials that existed, they could move oil to the east coast of the U.S., to the west coast of the U.S., to loading facilities on the Mississippi, where oil could be transferred to barges and barged down to places in Louisiana where it could be refined and so on. And all of that is really happening. There have been studies done. Environmental Protection Agency a number of years ago hired a consultant to look at safety records. And the way it works is pipelines are the safest way to move products like crude oil around. Next safest is barges and other large vessels. Next after that is railroads, and then next after that is trucks. So there are different environmental consequences of each of these things, and all of these things have to be weighed. What are the pros and cons of doing things? One thing that we have learned with railroads is that if you don't know exactly how long the boom is going to last in a particular area, doing things by rail, which has more flexibility in it than kind of the fixed pickup point and delivery points for pipelines, is kind of an interesting way of doing things, at least in the early stages. I suspect that eventually infrastructure will kind of catch up with these shifting sources of production in the U.S., and we're going to end up with pipelines doing more of it in the long run. But in new and developing plays, there's a fantastic opportunity, I think, for the railroad industry to move things.
Hello, I'm Chuck Samuel, and I was talking to a friend of mine the other day, and she's a retired driller. She worked for Exxon for a long time. We were chatting about the influence of the price of natural gas on drilling activity in natural gas. And what she said to me was kind of surprising. She said, Chuck, there are wells that make money at $1, and there's wells that can't make money at $7.50. Now, with that in mind, the question I wanted to offer is what we're seeing here maybe just the industry pulling out of what we call their less productive well pads and going for the places where they really know they can pump? And possibly in addition to, you talked about technology and maybe in lift improving, are they simply getting better at maybe finding where the fish are, if you will?
Sure, it's a combination of both those things. I mean, I think that clearly what happened when natural gas prices fell was that drilling rigs moved from the Marcellus in Pennsylvania to the Eagle Ford in Texas. And why did they do that? Because an oil well, the same rig could drill either an oil well or gas well, and the revenue from drilling an oil well was greater than the revenue from drilling a gas well, and so that's what you would do. Are there gradations? That kind of goes back to that issue of costs. I think you're exactly right. I mean, if you look at cost curves, there are places in the world where oil is profitable, at least to drill it and lift it at $3 or $4 or $5 a barrel. That's those big old wells. It's the Ghawar field in Saudi Arabia. There are other places where the marginal costs are much higher. If you kind of average it out, and we could kind of come back to this cost thing, there are a lot of people that believe that we're probably looking at a world where to sustain in the long term natural gas production in the U.S., given what we know about the cost curves, you're probably going to have to see gas at $5, maybe rising towards $6 a million BTU. On the oil side, it's probably $90 and going up. There are really interesting questions, though. I mean, if you were to have a global recession, it's certainly possible that demand could fall fast enough that oil prices could plummet. We saw that happen in 2009, and oil prices went well below that $90 number, and we began to shut production in a number of different places. Technology, it's a race, I think, between what the impact is of inflation and all of this infrastructure building and drilling is doing to the labor costs and material costs. What does it cost to make steel? What does it cost to hire a driller? What does it cost to get a welder? That's on one side, and on the other side is, can the drilling productivity itself increase? Coming back to EIA's drilling productivity report, what we're saying is that on balance, in the near term, right now, the productivity of drilling those wells is beating the decline by a fairly decent margin. And that margin is bigger in Eagle Ford than it is in the Bakken, but in both places, in fact, in all of these areas, the costs are sufficiently low to encourage further investment and growth in production.
Thank you. My name's Annie. I would like to thank you for at least mentioning the devastating environmental impacts of using oil and gas in our industry. Just recently, in the last referendum at Columbia College, 73% of students voted in favor of the college to divest from oil and gas companies. I wonder what's your position on that, being one college out of an entire national network of movements like this to divest from like industries. And also, from your studies, do you think we can actually afford to burn the resources that we have found to exist right now in terms of the greenhouse gases that we would put into the atmosphere and the amount of water that would be needed for hydrofracturing?
Right. So the way I like to think about the issues surrounding resource development is a Venn diagram. Does anybody here know what a Venn diagram looks like? Like three circles, right? So think of three circles, and I'll name the circles. The environment is a big circle, and we have to be able to deal effectively with the environmental issues surrounding resource development. The other one is an economic circle, and the economics are very important. GDP, jobs. Think about that. And the other one is national security. So I like to think of these three kind of big circles, and the policies that most people would agree make sense is where in that Venn diagram those three circles cross. So something that is not harmful, might even be positive for the environment, encourages GDP, economic growth and job creation, and is good for national security. So it's hard to find policies that meet all three of those criteria. The EIA just recently, within a few months, published our International Energy Outlook. And what we said in the International Energy Outlook is that most of the growth in energy consumption over the next 25 years is going to be coming in Asia, the Middle East, and Latin America, and not in the United States or North America, Europe, or the kind of developed countries in Asia. That of the growth for example, that we have total energy consumption growing by something like 56% between now and 2040. And that half of that growth is in two countries alone, China and India. The U.S. has reduced carbon emissions quite significantly since 2005. They peaked in 2005 at something like 6 energy-related carbon dioxide emissions, or 6 gigatons in 2005, and we're down below 5.5 gigatons now. A lot of that has come with growth in renewables and substitution of lower carbon natural gas for higher carbon coal in electricity generation. So hydraulic fracturing of natural gas shale formations is providing growth in a cleaner fuel. And I think, when you think of this Venn diagram, it's a balancing act. So what I would say is that in the United States anyways, that we're trying to balance off national security issues with environmental issues, with economic issues, and that's why we have a Congress, that's why we have an executive branch and courts looking at all of this to try to make those policy decisions that effectively balance those competing interests. One thing I think is pretty clear is that a lot of the environmental impacts that we're going to see over the course of the next 25 years are going to be coming from outside the United States, and getting some kind of an international agreement, maybe going back to the discussion or the question that was asked earlier is, would it make sense to encourage China to move towards cleaner fuels? And the answer is, I think it would.
Next question. And then probably have time for maybe one more if anyone else wants to come up to the microphone.
Justin Newman from the law school. Just, following up on the question earlier about infrastructure, has the EIA discovered or explored any possibility of the fact that there's maybe a lack of proper infrastructure in, for example, the Bakken region, which only a few years ago had just a few thousand people, and there's been suddenly a boom, just in terms of perhaps housing or manpower. Has there any indication that this lack of infrastructure is inhibiting growth in any way?
Has EIA done work on sort of jobs and lack of infrastructure in places like the Bakken? The answer to that is not really. That would be other parts of the federal government that would be responsible for that. One thing that we did take a look at, because it seemed and is very important, something like 30% of the gas being produced in North Dakota is being flared. You may have seen those satellite pictures that, nighttime satellite pictures. You see New York, Chicago, Los Angeles, and then what's that city? And and it's not a city. It's the flaring that's taking place in the Bakken. But it was higher than that. The numbers were closer to 35 or 36% a year ago. They're down to 30% now. There's a pipeline that's very close to being built that's going to take some of that gas to Chicago, and that number will drop from about 30% of the gas being flared to closer to 20%. So as we have enough time to begin to build the pipelines and so on to do that, how much of a problem is the flaring in the Bakken? One of the things that we do know is that if you add up all of the gas that's being flared in the United States, and there's flaring takes place generally when you find oil and gas and you don't have the infrastructure, you can get the oil out. The infrastructure for moving oil around with things like trucks and trains and so on is better than it is for natural gas. Is less than 0.5% of 1%. It's close to 1/3 of 1% of total production in the U.S. It's a pretty small number. And flaring is actually way better than releasing it as methane being a much more potent greenhouse gas. So flaring in infrastructure development in the Bakken, I think, is going to improve over time. one of the things that when you have a big boom in a place like North Dakota has the lowest unemployment rate of any state in the United States. So that's pretty good. But flaring of gas is not so good. And so I'm back to that Venn diagram. You got environmental issues and you have economic issues, and what policymakers have to do is to try to balance those two.
Okay, well, we have about 5 minutes left, but since I know you have another speaking engagement in Midtown, we'll give you those 5 minutes back, so to make sure you are on time. But I know everyone here has not yet had their fill of discussion about how the North American energy outlook is changing. So this is a double header, because at 6 o'clock, Paul Joskow, the president of the Sloan Foundation and one of the leading energy economists in the country, will be here for our Leaders in Energy series that Professor Manuel Pinho has sponsored for the Center on Global Energy Policy. And Professor Joskow will be talking about the outlook for natural gas in the U.S., what the implications of it are, and what this kind of shift from scarcity to abundance means. So I hope people will stick around or come back for that. That will also be a webcast for people who want to watch it online.
Jason, let me just mention in the last minute here the 2 items that are at the bottom of my list here of if you want to learn more. The State Energy Portal, Shirley Neff, who's here. Shirley, stand up and say hello to everybody. Shirley used to teach here at Columbia, and some of you were her students. Shirley is now working at EIA and has been instrumental in developing our state energy portal. We have some fantastic mapping capabilities there, and I encourage you to have a look at our state portal and the kind of information that was there. And the other thing that I would really encourage you all to do, if you are not already signed up to get the push every day, our Today in Energy. We have a daily product. This is a relatively new thing for EIA. We have lots of annual and quarterly and monthly and weekly products, but we never had a daily product. Richard Newell, my predecessor, started that and was very pleased to see that not only did I keep it, but I've tried to improve and enhance it. The Today in Energy really deals with a lot of these issues that you've been asking me about today, at least from the standpoint of what kind of data that we have that would shed light and help us answer some of these tough policy questions that are around across all of the fuels. And I'd really encourage you to have a look at Today in Energy and get yourself signed up for it. So thank you very much for inviting me here, Jason, and you.
Thank you.